Good morning students. Today's session will be learning regarding the rules of sum and product. In this section we'll be learning regarding the product rule. Based on this we have solved the second set of example problems. So let us see those examples. So the example 1 is based on a bit is either 0 or 1. The question is like a bit is either 0 or 1. A byte is a sequence of 8 bits. So you know that a byte, each byte, one byte is actually consisting of 8 bits. So we'll just write down here 1, 2, 3, 4, 5, 6, 7, 8. And you know that in this byte, it is a sequence of 8 bits. So this bit can be either filled in two binary values. So that is 1 odd 0, 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 so on. Okay, you can fill it in the form of 1 or 0. So over here they have told find a byte is a sequence of 8 bits. Find the number of bytes. Find the number of bytes. Okay, they have told that find the number of bytes. Now, how will you find the number of bytes? Is nothing but here a byte is a sequence of 8 bits. So number of bytes, since each byte contains 8 bits, and each bit is a 0 or 1. There are two choices. So the number of bytes can be nothing but two choices. How many positions? 8 positions. So it is nothing but 2 to the power 8. So I'll just write down the first answer over here. And since each byte contains 8 bits, and each bit is a 0 or 1, therefore the number of bytes is nothing but option you have is you can fill a byte in terms of 1 and 0, like here also 1 0 1 0. Possible values you can fill is these two binary values. So there are two values. How many positions are there? 1 2 3 4 5 6 7 8. So it is 2 to the power 8. So the number of bytes is nothing but 2 to the power 8, and the answer is nothing but 256. So this is regarding the first question. Then they told that the number of bytes that begin with 1 1 and end with 1 1. That means in the second question they told that find the number of bytes that begin with 1 1 and end with 1 1. So totally how many locations we have? 1 2 3 4 5 6 7 8. So they told that begin with 1 1 and end with 1 1. That means what? These positions are already been occupied. Okay, that is they should begin with 1 1. Okay, and they should end with 1 1. So in a byte beginning and ending with 1 1, there occurs these 4 positions, 4 opening positions. So how can these be filled? How can these be filled? So these can be filled in how many ways? You know, again 0 or 1 0 or 1 0 or 1 0 or 1. So possible is 2, and there are 4 open positions. So that is nothing but 2 to the power 4. So I'll repeat, in a byte beginning and ending with 1 1, there occur 4 open positions. There occur 4 open positions. These can be filled in 2 to the power 4 16 ways. Therefore, there are 16 bytes. Therefore, there are 16 bytes which begin and end with 11. Which begin and end with 11. Okay, so why we have 2 to the power 4? See, they have told already it should begin with 1 1. So this position is already been fixed. This is fixed. This is fixed. This is fixed. Okay, number of bytes that begin with 1 1 and end with 1 1. So these bytes, right? Obviously, it is like if you find these remaining bytes which actually occupy. So you know these possibilities are 0 1 0 1 0 or 1 0 or 1. So open positions is 4. So it is 2 to the power 4. Now third question is the number of bytes that begin with 1 1 and do not end with 1 1. That begin with 1 1 and do not end with 1 1. That means what? 1 1 it should begin, and here possible position is 1 2 3 4 5 6. They have told that it begin with 1 1. So what are the possible open positions you have? 2 to the power 6 actually, but that may be the possibility of ending with 1 1 also. Okay, so this should be filled with 0 or 1, but our question is the number of bytes that begin with 1 1 and do not end with 1 1. So this gives actually end with 1 1 also. So that we have to subtract, which is going to end with 1 1 also. So you had seen in the previous problem that begin with 1 1 and end with 1 1, right? So begin with 1 1, okay, fine. Begin with 1 1 condition is fine. This is end with 1 1. So I don't want end with 1 1. So how many ways are there? End with 1 1. It is nothing but 2 to the power 4. So I just separate 2 to the power 6 minus 2 to the power 4. So we'll get it as 2 to the power 6 subtracted by 2 to the power 4. So that is nothing but 64 minus 16, that is 48 ways you will get the number of bytes that begin with 1 1 and do not end with 1 1. So I'll repeat if you want. They told begin with 1 1, so 1 1 I filled, so I cannot rearrange this, it's fixed. Rest 6 terms I need to rearrange. So how can I rearrange those 6 terms in 2 to the power 6? But condition is last 2 should not end with 1 1. But this, if I arrange, it is giving this 2 to the power 6 is giving me the value or answer which is ending with 1 1. Okay, so I need to subtract the one which is ending with 1 1. So in the previous example we solved, begin with 1 1 and end with 1 1, number of ways is 2 to the power 4. So here begin with 1 1 and end with 1 1 also is giving what? 2 to the power 4. So 2 to the power 6 minus 2 to the power 4 is nothing but 64 minus 16, that is equal to 48 number of ways. So this is the answer for the third question. Next is regarding the fourth one. The number of bytes that begin with 1 1 or end with 1 1, that begin with 1 1 or end with 1 1. So we actually need to find over here is the number of bytes that end with 1 1. So we'll see this fourth question, the number of bytes end with 1 1. The number of bytes that begin with 1 1 or end with 1 1. So it is like nothing but you have to use this particular formula, A union B. A union B is nothing but just A, just B minus A intersection B, A intersection B. So what is this formula? This is where the number of bytes that begin with 1 1 and end with 1 1. So what is the value of A union A intersection B? Begin with 1 1 and end with 1 1. Here we have, it begins with, union of both, begin or end. So that formula we are using, that's it. The number of bytes that begins with 1 1 or end with 1 1. So that means what? If this is an A, and if this is a B, this is A intersection B. So this is only A and this is only B. So A, I need to find or that begin with 1 or end with. That is nothing but I need to find A union B. So just A you try to find out, just B that means that just begin with 1 1, just end with 1 1 and minus both, begin and end with 1 1. So this value I know, minus A intersection B, that begin with 1 1 and end with 1 1 value is minus 16. What about just B? Let us take A as that begin and end with 11 is 16. You know that, okay, begin and end with, therefore the number of bytes that begin or end with 11. So just see over here, just to begin with 1 1, you just see, begin with 1 1 means 1 1. Possible I have to arrange is 2 to the power 6 ways. If it is end with 1 1, 2, 3, 4, 5, 6, 1, 2. End with 1 1 also, these 2 to the power 6 ways. So this is 2 to the power 6 ways I have to arrange, even while ending also I have to arrange 2 to the power 6 ways. So A, if you take it as beginning with 1 1, then possible arrangement is 2 to the power 6. Plus B, if you want to take end with 1 1, then it is again 2 to the power 6. So what is the value? 2 to the power 6 plus 2 to the power 6 minus 16. So that is nothing but 2 to the power 6 is what? 64. 64 plus 64 minus 16. So totally we get it as 1 1 2. So this is nothing but they are using the concept of A union B, A union B, A union B. Okay, so this is regarding A union B. So I'll repeat the entire problem. A bit is either 0 or 1. A byte is a sequence of 8 bits. So remember, a byte is always a sequence of 8 bit which is filled by bits, that is 0 or 1. Find the number of bytes they are told. So these bytes can be filled in how many ways I have told? 2 to the power 8 ways. So directly 2 to the power 8. Why 2? 0 or 1 possibility. Next they have told number of bytes that begin with 1 1 and end with 1 1. So I filled beginning 1 1, end with 1 1. So what are the possible ways I need to arrange? So these 4. So So answer is 2 to the power 5. Next they have told the number of bytes that begin with 1 1 and do not end with 1 1. So beginning with 1 1 is fine. Next I have to arrange 2 to the power 6 ways, but it also includes end with 1 1. So I need to separate with end with 1 1. So begin with 1 1 and end with 1 1 is already been solved. So I took minus 2 to the power 4. So 64 minus 16 you got 48 ways. Here the number of bytes that begin with 1 1 or end with 1 1, that begin with 1 1 or end with 1 1, meaning is what? It might begin with 1 1 or it might end with 1 1. So the formula I have used is nothing but A union B. The formula is modulus of A modulus of B minus modulus of A intersection B. What is A intersection B? A union B is begin with 1 1 or end with 1 1. A intersection B is exactly opposite of that. So what it will be? It must begin with 1 1 and it must end with 1 1. This is an OR condition. It may begin with 1 1 or it may end with 1 1. It must begin with 1 1. It must begin with 1 1 and it must end with 1 1. That is this. What is just A? Possible way when you will arrange when it begins with 1 1. Remaining ways is 2 to the power 6. What is B? It is possible 2 to the power 6 ways you will arrange. Ending is should be 1 1. So we know 2 to the power 6 plus 2 to the power 6 minus A intersection B. That is nothing but begin with 1 1, end with 1 1. We add 2 to the power 4. So that is 16. So totally 64 plus 64 minus 16 equal to 1 1 2. So this is regarding the example 1. Example 2 is based on find the number of 3-digit even numbers with no repeated digits. So what they have told us, you have to find a 3-digit even numbers with no repeated digits. So how, for example, I'll just show you what is the example I can take. It should be an even number. So obviously the ending section, whatever it should be, the possible is even numbers is 0, 2, 4, 6, 8. Okay. So this is the possibilities. If you want to make this entire number as even, and then he has put a condition that we should not have any repeated digits. For example, ending can be with integers is 0 to 9. That is totally there are 10 digits. 10 digits, that is 0, 1, 2, 3, 4, 5, 6, 7, 8 till 9. So you have 10 digits. But at the end you can have only 5 possibilities. Here you can have 5 possible ways because it should be uneven, right? So it should be either end with 0, 2, 4, 6. So 5 possible ways. And here in the X you can have only 9 possible ways. Why? Integers are 0 to 9, 10 integers I can fill. That means like 0, 1, 2, 3, 4. But in X, since it is a 3-digit even number, if you put 0, then it will be a 2-digit even number, right? So excluding 0, how many possibilities are there? 9 possibilities. So that 9 possibilities I can fill over here. But in this case, I can have all 10 possibilities. 10 integers, that is either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Till that you can have 10 possibilities. Here it can have only 5 possibilities. Here you can have 9 possibilities because I am excluding 0, and in the middle position I can have 10 possibilities. Now this is what condition he has mentioned. Here I can have 9, here I can have 10, and here I can have 5. But again, while I end with 0 here I can have some possibilities, and while I don't end with the I end with the even numbers, here I will have certain possibilities. I'll explain those criteria. Before that, what should be a number? So for example, you can have like 5, 6, 2. So this is what he is expecting, 3-digit number. You cannot have 5, 5, 2 because repeated digits are not allowed, or something like 5, 6, 6. These things are not allowed. So these possible examples are not allowed. So let us come back and we'll solve. So let us take consider the number of the form in X, Y, Z. Okay, X, Y, Z. So just write there. Here we consider number of the form. Here we consider the number of form. Here we consider the number of the form X, Y, Z, where each of X, Y, Z represents a digit. Okay, these all are nothing but they are representing a digit. As I told, there are 10 digits, so these represents a digit. So you can write represents digit. X, Y, Z represents a digit. Okay, a digit. Over here, since X, Y, Z has to be even, since X, Y, Z has to be even, yes, that is our condition, has to be even, then Z has to be, ending Z has to be 0, 2, 4, 6, 8. That's what I told. Z can have the possible 0, 2, 4, 6, 8. So let us write here. I'll just write here. It can be having the possibility 0, 2, 4, 6, 8. Now I told this has 9 possibilities. This has all 10 possibilities. This has 5 possibilities. Now when Z is ending with 0, imagine Z is ending with 0. So one position is occupied. So remaining 4 digits are left. Already one is occupied. When Z is 0, X has how many possible ways? X has 9 possible ways. Okay, X has 9 possible ways. That is what one condition. Now when Z is any other condition like 2, 4, 6, 8. Okay, if Z is 0, then X has 9 possible ways or choices. And if Z is 2, 4, 6 or 8 4 choice, then X has 8 choices. Why X has 8 choices? If it is ending with this, here it should not be 0, and possibility of that also, like if it is 2, 4, 6, it should not, 1 is already occupied over here. So remaining is, see here when it is 0, here 9 possibilities there when ending with 0. So one position from this 9 minus 1. So 9 minus 1 is nothing but this. 9 possibility was there. Now this is already been done. So 9 minus 1 is, or left out is 8 ways when this condition is there. Like if you want to see, like when you have 0, it is X, for example, when X is X and Z delta, right? When it is 0, this has 9 possibilities. When this is 2, this has 8 possibilities. When this is 4, this has 7 possibilities. When this is 6, this has 6 possibilities. When this is 8, this has 5 possibilities. So these are the possibilities when this condition is there. But we know that when this is there, X can be directly arranged in 8. Only when the 0 conditions I have to check. So I wrote when Z is 0, this has 9 possibilities. When this is 2, 4, 6, I have remaining this 1 minus, that is 8 possibilities. So this can be arranged in, when Z is 0, this is 1 way and this has 9 ways. When this is 2, 4, 6, that is 1, 2, 3, that is 4 ways. I have 8 possibilities of arranging them. 8 possibilities of arranging them. So when this is, so what I can write over here is, if Z is 0, then X has 9 choices. You know that if Z is 0 means what? Remaining 1 to 9 should be arranged. 0 is gone, 9 choices. Okay, and if Z is 2, 4, 6, 8, then X has 8 choices. Because already X had 9 choices, but when Z is 0, one choice is already, one digit is already been occupied by the X position. See here, when Z is 0, out of 1 to 9, one position is occupied. For example, you imagine when Z was 0, 1 was occupied. How many terms are remaining? 8 digits are remaining. That 8 digits can be used for these remaining positions. That's what, when if Z is 2, 4, 6, 8, then X has 8 choices. I hope it's clear. Then just we'll see how can we arrange these XZ. So X and Y, X and Z, therefore Z and X or X and Z can be arranged in 0 is one arrangement, right? So 1 into, X is, X and Z, right? X and Z. So when you take Z as 0, it is only one arrangement. So this is arrangement of Z into X. How many times I can arrange? Remaining, if this 0 is occupied, remaining elements I can arrange is 9. So X and Z can be arranged in 9 into 1 plus this 9, one position is occupied, this 8 ways into remaining 4 even digits. So 8 into 4. So this is equal to 41 ways I can arrange X and Z. Now we'll see why. You know that out of 10 digits, 1 if this is occupied, 1 if this is occupied, remaining is what? 8 ways. So for each of these ways, Y can be arranged Y can be chosen in 8 ways. Y can be chosen in 8 ways. Hence, the desired number is, the desired number is 41 into 8, that is equal to 328 ways. 328 ways. So this is how we are going to solve the problem. So just I'll repeat. We first took of arrangement of x. So just consider, out of 10 digits, if x occupies 1 and z occupies 1, remaining y can be arranged in 8 ways. I told y can have 10 choices, but if this occupies and this occupies, this can be arranged in 8 ways. And this add 5 possibilities. If this add 5 possibilities, nothing but 0, 2, 4, 6, 8. Okay, 0, 2, 4. If z is 0, x add how many positions? 9, because 0 is already been occupied. So x add 9. But this cannot be 0, right? This cannot be 0. If this cannot be 0 means, it should end with 0 actually here. Okay, this cannot be 0 means it should end with this. So for the remaining choices, right, like for 2, 4, 6, 8, here it cannot be 0. It cannot be 0. One is that, and when it cannot be 0. So what is happening? This position is already been occupied because 0 is over here. So 9 possible ways was there. Because 0 is here, no repetition, so 9 possible ways. Now, this out of this 9, 0 is gone. Now what happened? You remove that. One position is already been occupied, so remove that position. So left out is how much? 8 possible ways. Because one way is already been used, left out is 8 possible ways. In that 8 possible ways, this can be ended with these many numbers. So it is 8 into 4. So 9 into 1 possible, 9 into 1 possible, 8 into 4. That's what I have written. And why I wrote 8 ways. So this is what is regarding the example 2. In example 3, they are told that how many among the first 100,000, that is here I missed 10, it is 100,000 positive integers contains exactly 1, 3, 1, 4 and 1, 5 in their decimal representation. So question is actually 100,000. Okay, how many among the first 100,000 positive integers contains exactly 1, 3, 1, 4 and 1, 5 in their decimal representation? So if you check over here, what they have told is the number, you check with the number 100,000, whether this contain any 3, 4, 5. So it does not contain. It doesn't contain 3, 4, 5. So the number, you can write just the number 100,000 does not contain 3, 4, 5. Therefore, we can, how many among the first they have told? So this number does not have 3, 4, 5. Less than this number is what actually? It is nothing but max, you can check till 999. That is till here. So how many positions are there? There are 5 positions that we have to check. So how many among the first 100,000 positive integers they are told? So this number does not contain. So less than that max is this number. Contains exactly 1, 3. Exactly 1, 3, 1, 4 and 1, 5. Meaning is nothing but in this number there should be only 1, 3. It may be in any 5 places. There should be only 1, 4. It may be in any 4. Either 4 here. And there should be only 1, 5. That is what in the decimal representation they are told. So if I want to place 3, then how many choices I have to place the 3? I have 5 choices. I can place 3 over here, 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 I can place 3 over here. That means 5 choices I have. The number cannot be this way. Why? Because they told that should contain only 1, 3. So once this arrangement is nothing but, meaning of this arrangement is nothing but, in that 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. In this way, if 3 is over here, 3 can be here, 3 can be here, 3 can be here, 3 can be here. That means other numbers can be filled over here. So for 3, how many ways are there to arrange? There are 5. How many among the first 100 contain? Exactly 1, 3. So if I take first number as 3, then 3 can be arranged in 1, 2, 3, 4, 5 ways. So if I take these arrangements, 3 can be arranged in 5 ways, right? So I can arrange in 5 ways. So let 3 can be arranged in 5 ways means remaining place, this has been occupied. How many places are there? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. So next is exactly 1, 3, 1, 4 and 1, 5. So 4 can be arranged in what? 3 is already occupied. Remaining places are 4. Next 5 can be arranged in how many ways? Now for example, if 4 is over here, somewhere 4 is over here, somewhere 1, 2, this has been occupied, somewhere 4 might be over here, somewhere 4 might be over here, again somewhere 4 might be over here. Like I'm just giving a random example. Right? 4 can be arranged in how many? 4, these 4 places anywhere, right? These 4 places, but only thing is it should not be repeated. That's it. 4 can be arranged in anywhere. It should not be in, like, it may not be in this pattern itself, but it should not be in, it should not be repeated. So 4, actually to fill the 4 you have how many positions? 1, 2, 3, 4. In this number 4 again it should not repeat. So 4 has 4 ways. Now 3, 4 is filled. Now next is 5. 5 in their decimal representation. So 5 can be filled in how many ways? 1, 2, 3. Any out of these 3, any one position I need to fill 5. So 5 has got 3 choices. So 5 can be filled. 5 can be filled in 3 choices. So 3 had, if you see here, 1, 2, 3, 4, 5. 3 I could fill in anywhere, but I had how many choices? 5 choices when it was 3. But 4, if I fill 3 over here, 4 I can be filled in any place, but only one decimal representation, right? So one decimal representation. So 4 can be filled in 4 ways. Then 5, if I filled 4 over here, then 5 could be filled in 3 ways. This was for 5. Now for example, let me see 5 I filled over here. Now left out is 2. These 2 should be filled with any again decimal. So you know digits you have 0 to 9, 0 to 9. So in that 0 to 9, no repetition, right? So exactly 1, 3, 1, 4 and 1, 5 must appear in their decimal representation. That's what they told. So 5, out of this you remove 5 number, you remove 3, you remove 4, because mandatorily it is told positive integer contain exactly 1, 3, 1, 4, 1, 5. That means they should appear. Remaining how many numbers are there? 7. So what are the possible numbers that can occupy here? 7 and 7. So this is the answer. So let us write in the form of theoretically. The number 100,000 does not contain any 3, 4, 5. Therefore, we consider all possible. Therefore, we consider all possible positive integers. Therefore, we consider all possible positive integers with 5 places. That meet the given condition. Okay, that means the given condition. In a 5-place integer, okay, in a 5-place, you need to write these statements. In a 5-place integer, 3 can be in any one of the 5 places. 3 can be in one of 5 places. Simultaneously, what about 4? 4 can be in, write down here, 4 can be in any one of the 4, in any one of the remaining 4 places, one of the remaining 4 places, and 5 can be in remaining 3 places. 3 places. There are 2 places left. May be filled with 7 digits. Okay. So answer will be thus. Therefore, it is 5 into 4 into 3 into 7 into 7. So that is equal to 2940 integers. 2940 integers. So this is regarding the example 3. So example 4, they've told that find the total number of positive integers that can be formed from the digits 1, 2, 3, 4 if no digit is repeated in any one integer. So total number of integers you have to find, positive integers you have to find. So if you total number of positive integers, let us take, I'll tell you, S1, let us take S1 with only single digit. Okay, that means total number of digits. Here told find the total number of positive integers that can be formed from the digits 1, 2, 3, 4. You know, either you can form single digit, either you can form double digit, either you can form 3 digits, either you can form 4 digits. Add single digit, double digit, third digit and fourth digit, 4 digits. So this is what is our required answer. That is find the total number of positive integers. So you can find the number with single digit, you can find it with a double digit or 3 digit or 4 digit. Max, why 4 digit? Because we have the numbers only 1, 2, 3, 4. And condition is if no digit is repeated in any one integer. Okay, so just tell me, if I want to play with a game like 1, 2, 3, 4, that is one digit. If I want to form one digit, what are the possible ways I have? Either I can have only 1, either I can have only 2, either I can have only 3, either I can have only 4. So these, how many ways you have? S1 can be arranged in 4 ways. So only since it is only one digit, S1 let it be a number, or else we'll take, we'll consider S1 as a number. S1 number of integers of the required type of 1, 2, 3, 4, 3. We'll tell S1 is of, we are finding a one digit number. Okay, one digit number. So it is 1, 2, 3. So totally S1 we got it as 4 ways. Now when I tell it for 2 digits, I'll write S2 over here. When it is S2 is for 2 digits, what will happen? Condition is 2 digits, right? So out of this I can occupy what? 1, 2, 3, 4 itself. So for example, if I occupied 1 over here, can I occupy 1 over here? No. Why? Because no repetition. So here any number out of these 4 numbers can be arranged in how many ways? 4 ways, because there are 4 numbers, 1, 2, 3, 4, 4. Now out of this 4, for example, let 1 be occupied, remaining should be 3, right? So 3 will be occupied here. So totally it is 4 into 3, we have 12 ways for 2 digit number. Similarly, S3 is 3 digit. So if this occupies 4 ways, 1 is already occupied. For example, 1 number is occupied over here. Remaining is 2, 3, 4. So what are the possible number of ways of arranging 2, 3, 4? 3 ways. Imagine 2 is already over there. Now 1 is here, 2 is there. Repetition is not there. So left is 3, 4. 3, 4 can be arranged in 2 ways. So it is 4 into 3 into 2. 4 into 3 into 2. So that is nothing but 4 3s are 12, 12 2s are 24 ways. That is for S3. Last is S4 because 4 digits are there. So 1, 2, 3, 4. So this has 4 possible ways. You can arrange in 1, 2, 3, 4. And next term, like no repetition, right? So 1 reduction, 3. Again no repetition. So 2. Again no repetition. It is 1. So it is 4 into 3 into 2 into 1, 2 into 1. So it is nothing but 4 3s are 4 3s again it is 12, 12 2s it is 24 ways. So this is the possible ways you can arrange. Example, if you tell S1 is 1 digit, so they told total number of digits, right? So it is nothing but S1 plus S2 plus S1 plus S2 plus S3 plus S4. So that is nothing but 4 plus 12 plus 4 plus 12 plus 24 plus 24. So that is total number is nothing but 64 ways. 64 ways. So this is the required answer. I'll repeat. Find the total number of positive integers that can be formed from the digits 1, 2, 3, 4. Total number of positive integers. So it can be a single digit, it can be a double digit, it can be a 3 digit, it can be a 4 digit number. And no repetition. If it is single digit, you know, either you can have 4 possible ways. Once you can have just 1, once you can have just 2, once you can have just 3, once you can have just 4. If it is 2 digit, for example, let us consider 21. So what is the possible way? There is no repetition, right? If it is 22, it's wrong. We don't satisfy our condition. So 2 is been occupied. So remaining how many? 2 is been occupied. So this we had 4 ways. Okay, out of that 4, 2 is been occupied. If 2 is occupied, 1, 2, 1, 3, 4 is remaining. So that can be arranged in, and 2 is occupied. 4 ways, okay, 4 ways. 1, 2, 3, 4 can be arranged in 4 ways. If 2 is occupied, remaining is 3 elements. So 4 into 3. Similarly for 3, 4 into 3 into 2, it is 4 into 3 into 2 into 1. So this is how you are going to find the total number of ways. So you can just tell that first we know that S1, S2, S3, all these S1, S2, S3, S4. let S1, S2, S3, S4 denote the number of integers of the required type. Denote the number of integers of required type containing 1, 2, 3, 4. Okay, 4. Since there are 4 digits, I'll write, you can write this from here, the statement. Since there are 4 digits, S1 is equal to 4. S1 is equal to 4. That is, S1 is nothing, containing only 1 digit. Containing 1 digit. Comma. There are 4 into 3, that is equal to 12 integers. 12 integers containing exactly 2 digits. That is, S2 is equal to 12. There are 4 into 3 into 2, 24 integers containing exactly 3 digits. That is, S3 is equal to 24. And there are 4 into 3 into 2 into 1, 24 integers containing exactly 4 digits. Containing exactly 4 digits. That is, S4 is equal to 24. Therefore, required is nothing but S1 plus S2 plus S3 plus S4, that is equal to 64. So this is the required answer. Our last example is based on find the number of proper divisors of 44100. So the meaning of proper divisor is you should find a positive integer, but excluding this n and 1. Okay, proper divisor is excluding this n as well as the last what we get as the remainder as 1. That is nothing but the meaning of the proper divisor. So we should find the number of proper divisors of this. So let us first find the divisors of this. So let us solve over here. 44100. So this is divisible by 2. So let us take like 2. It will be 2, 2, and this, since it is 1, 0, and then you will put it as 5, and then again followed by 2 zeros. Then again you will divide it by 2, so it will be 1, 1, 0, 0 as it is. 5 is nothing but 2, so it is 4, so 1 again it is 5, 2, 5, 0, and then again this can be made divisible by 2 itself. So if you take it as 2 or 5 also you can take. I take 5. So 5 2s are again 2s are, then 0 5 0 you'll get 0 5 0 0 5 0. Then again you take 5. So it is 4s are, again 4s are, then 1 0. And again you it is divisible by 5. 4 8s are, 8s are, 2s are, and then again 2 I'll take. 4 4 1 I'll get. Then again 7 42, 6 7 6 are 42, so it is 6, and then 3 21 is remaining. I mean 42 2 and 1 21, so 7 3s are 21. Then again 3 I'll take, so 3 2s are and 1s are. Then again 7 3s are, then again 3 and then 1. Finally 1 is the remainder. Okay, 1 1s are, you'll get it as 1. So this is how these are the divisors of 441. We know that it has 2. How many 2's you have? 2 to the power 3 you have, and then you have 5 to the power 3, and then you have 3 to the power 2, then you have 7 to the power 2. So this is nothing but these are the divisors of this particular number. So what we'll write is, we'll write this particular divisor as it is. We note that 441, that is nothing but 2 to the power 3 into 5 to the power 3 into 3 to the power 2 into 7 to the power 2. Therefore every divisor of n equal to 44110 must be of the form d is equal to 2 to the power p into 5 to the power q into 3 to the power r into 7 to the power s. Okay, where p is nothing but 3, right? So p ranges where p is ranging between, p is actually ranging between 0 to less than 3, right? 3, and q is 5. Again q is again between, where that is ranging from 0 to 3. Q is also same, 0 less than q greater than or equal to 3, and this is r, right? So r is nothing but should be less than or equal to 0. I mean r should be less than or equal to that till where, till 2, and s is again same, 0 less than or equal to s greater than or equal to 2. So it is ranging for over here. So for a divisor D, so for a divisor D P can be chosen in 4 ways, that is 0 to 0 1 2 3. So it is 4 ways, and q in 4 ways, because it is again 0 to 3, so it is also 4 ways, and r in 2 ways, yes again in 2 ways, okay. So it can be chosen in so many ways. So that's why, therefore, the number of possible D's is the number of divisors. That is not, D is nothing but the divisors. The number of possible divisor is 4 into 3 into 4 into 3. So that is equal to 144. Of these 144 ways, okay, 144 ways. If you want to find a proper divisor, we should exclude this n as well as this 1. The meaning is nothing but, for a positive integer n, the divisor of n other than 1 and n are called proper divisors. So I told the divisors total number is 144. So of these you should subtract these two divisors. So it is, therefore, of these namely 1 and n, you can write like this, of these 1 and n is nothing but 441 1000, 1 and n are not proper divisors, they are not proper divisors. So therefore the number of proper divisors is 144 minus 2, so that is nothing but equal to 142. So this is how we are going to find the number of proper divisors. So I'll repeat, find the number of proper divisors. When you find the proper number of proper divisors, in the concept of proper divisors, you're excluding this as well as 1. So I found all the divisors over here. I got 2 to the power 3 into 5 to the power 3, 3 to the power 2, 7 to the power 2. But actually this 2 is, we are arranging it from 0 to 3. That means there are possibly 2 to the power 0 is 1, 2 to the 0 is 1. So either 2 to the power 0, 2 to the power 1, 2 to the power 2. So that range actually from Here p, I wrote to 3 as p, so that p can range from 0 to 3. You know that it can be just 2 to the power 0, or it can be 2 to the power 1, or it can be 2 to the power 2, or it can be 2 to the power 3. So this can be having only one, right? 2 to the power 0. So that is 0, 1, 2, 3. So total possible ways 4. That's what I've written over here. Q is nothing but 5 to the power 3. So similarly Q is in 4 ways. R is again in 2 ways. R in 2 ways and S in 2 ways. So finally those ways I have to find. The number of possible divisor is 4 into 3 into 4 into 3, that is 144. Of this I am excluding 1 as well as the n. 1 as well as the n. So that is nothing but, for a positive integer n, the divisor of n other than 1 and n are called proper divisors. So I excluded those. So finally 144 minus 2 is nothing but 142. Thank you.